Okay, linear equations, graphs, and slopes. So first of all, we've been talking about linear equations in this course, but now we're going to talk about linear equations with two variables. And so all that means is we're going to have two number lines, right? Two number lines. So we'll have two variables in our problem. And we can represent them on what's called a Cartesian coordinate system, or what's commonly called as just a graph. And the reason that we have to just do a graph is because let's look at these equations that we've been looking at, these linear equations. If I say x plus 2 equals 3, right, and we do our process for solving that equation, and we find out that x equals 1. That's our only possible answer. X is 1, so I can just state it. But what if we had x plus y equals 3, and I had two variables in there? Well, now one answer is, of course, let x be 1 and y be 2. That's possible. But I could also have, what if x is 2 and y is 1? There's another possibility. I could have x is 0 and y is 3. There's another possibility. I could have x is 1/2 and y is 2.5. And that's also 3. I could go on and on and on. So when we introduce two variables, all of a sudden we have this infinite number of possible solutions. And so our solution to that is, let's draw a picture of what that solution looks like. You know the old saying, a picture's worth 1,000 words. So that's why now when we have two variables, an x and a y, we're going to draw our answers on the graph. Okay, if I just have one variable, I can solve it for that variable. So we're going to start graphing now. Okay, and so before we do that, let's just get a little bit of terminology out of the way. Like I said, this really is just two number lines, where this horizontal one is called the x-axis, okay, and the vertical one is called the y. Students always get confused and have a hard time remembering which one is which. So think about the y. I can write, whatever, a capital Y so that it has a vertical component to help me remember that, oh, the y goes on the axis, it's going up and down. No matter how I write an x, uppercase, lowercase, cursive, it doesn't have a vertical or horizontal component. Okay, but a y I can write so that it has a vertical line on it. That might help me remember that that's the vertical axis. Okay, and these, like I said, they're just number lines. So let's imagine this is 0, 1, 2, 3, 4, and then we've got -1, -2, -3, on and on. If I took this axis and just twisted it this way, right, twisted it, that's my other axis. Okay, so that's all it is. It's just two axes, is plural, put together. Now, this point right here where they cross, where they intersect, that's called the origin, right? This point right here. And that is where x is 0 and y is 0. Now, every point on this grid can be interpreted with an x value and a y value. You can call them coordinates, you can call them points, you can call them ordered pairs. Right? 3 different names for the exact same thing. Ordered pair is probably the best term because it's the most descriptive. It tells you you have to have a pair of numbers. So in other words, there's 2 of them, and the order matters. However, we're lazy, and so we usually use the word point because it's the shortest one, right? But ordered pair, the order matters, and just like in the alphabet, X comes first. So the point, the coordinate for the origin is x is 0, y is 0. And we write those coordinates inside parentheses with a comma between them. If I put a point right here, Then x is 1, 2, 3, and y is 1, 2, 3, 4, 5, 6. So this is the point where x is 3, y is 6. If I have a point right here, x always comes first. So I go back, I start at the origin. Origin means beginning, right? So you always start at the beginning and you count on the x-axis first. So -1, -2, -3. X is -3 to get to that point. And then the y, you go up 1, 2. Okay? Points that lie on an actual axis are called our intercepts. Intercepts. So if I have a point right here, because it's on the y-axis, that's the y-intercept. Okay? And because I did not move right or left any, I'm on this axis, the y-intercept always has a 0 in the x place. So -1, 2, 3, 4, and a number in the y place. Okay, this point is the x-intercept because it's on the x-axis. Okay, so I move over 1, 2, 3, 4, 5, 6, but I don't go up and down any, so the y is always 0 on the x-intercept. On the x-intercept, you'll have a number in x, 0 and y. On the y-intercept, you'll have a number in y, 0 on x. Okay? And then quadrants. The prefix quad means 4. When we turn these number lines this way, it breaks our graph up into 4 regions. Right? This region, this region, this one, this one. And they're labeled 1 through 4. And they start right here where x and y are both positive. Now why they go counterclockwise, I don't know, but then they go this way. 1, 2, 3, 4. Okay, so you're going to be asked what quadrant particular points are in. Notice if both points are positive, it's in the first quadrant. In this quadrant, the x's are negative and y's are positive because to get up here, you've got to go backwards on the x, up on the y. Down here, everything's negative. Look at this point is -1, 2, 3, 4, 5, 6, 7. And then I'd have to go down -1, 2, 3, 4, 5, 6. In this quadrant, your x is positive, y's are negative. Okay? A point that's on the actual axis, now they're going to try to be tricky about that and ask you which quadrant those are in. They're not in a quadrant, right? So your answer is they are not in a quadrant, okay, if it's on an actual axis. Okay, so let's think for a minute about what these things are going to look like. Let's take that equation we started with earlier and just get some points. Now normally what we do is we make this little, some people call it a T chart, a T bar, a T diagram. Notice I drew a big T to start with. And we'll just plug in numbers here. So if x is 0, y is 3. If x is 1, y is 2. If x is 2, y is 1. I'm just plugging in numbers here that add together to get 3. Let's do the 1/2. If x is 1/2, y is 2.5. What if x is -2? Then y is 5. And I could go on and on forever. Let's plot these points. X is 0, y is 3. X is 1, y is 2. X is 2, y is 1. X is 1/2, y is 2.5. Kind of right in there. X is -2, y is 1, 2, 3, 4, 5. Notice what happens. Wow, they're all in a line. So I could even extend this line, and what that means is every point on this line is a solution. Look, here's one. 0, 1, 2, 3. Oh, we already had that one, but look at this one. 1, 2, 3, 0. Another solution. 3, 0. Look at this point right here. That's our 5, -2. So let's look at this point right here. -1, 1, 2, 3, 4. Every speck, every point on that line is a solution. That's actually why these are called linear equations, because their graph makes a line. Now, as soon as we realize that, hey, every single graph that I'm looking for, if it's a linear equation, and that's all we're going to do in this course, is going to be a line. Well, if I need to draw a line, all I need are 2 points. I could have drawn this same line with that point and that point. I could have used this point and that point. Any 2 points. So now all I need is 2 points. And the only difference in one line and another line, the only difference in these, because they're all just straight lines, is where they're located and how much they are sloping. So all of a sudden this idea of slope becomes really important for us. Okay, so let me draw some lines up here. I wish these graphs were a little bigger, but we'll deal with it. Let's draw this line. Let's draw this line. And let's draw this line. Okay. Now these are all located in the same place. They're all going through the origin. So the only difference is this one's steeper and this one's kind of in the middle for steepness, and that one's less. Slope is just a measure of steepness. How steep is your line? And so all we do is compare, and a lowercase m is reserved for slope. It always means slope. So all I have to do to find the slope is measure how far up you have to go compared to how far over. So let's start at that origin. And if I go up 1, 2, and then over 1, up 2, over 1, that slope is 2. If I go up 1, over 1, I get to that point. So that slope is 1. On this one, if I go up 1, I have to go over 2. Up 1, over 2. So notice, this one is steeper. It has a slope of 2. This one's the least steep with 1/2. Order is really important in our slope. If I did it the other way around, if I went over first, over 1, up 2, over 1, up 2, and then this one, I would go over 2, up 1, then I'd be saying, oh, this one's got a bigger slope. It's more steep. And we can see from the line that that's not true. So our order is really important. You have to do the y's over the x's. Y's over x's. And some people call it rise over run, because this is rising, this is running, right? Rise over run, y's over x. And we have a formula that we have to memorize. These little subscripts here, they only mean the location of your point. You got to have 2 points, right? Any 2 points, then I can find the slope of that line between them. Any 2 points, I can find the slope of the line. So this is just saying the second y point, the first part, the first point. Second x, first x. Okay, and it's telling me I got to subtract in the same order. Think about this. If I wanted to find the slope of this line by looking at the points, right, I would do, so this is the point, 0, 0, and this is the point, 0, 2. That's not the point 0, 2. I want this point. Sorry. This point is 1, 2. I don't want on that axis. That's not where my point is. All right. So subtract the y's first. 2 minus 0. And then the x's. 1 minus 0. And notice we get the same thing, right? Okay, so I got a formula for slope that I got to memorize. Now, there are 4 things that can happen with your slope. It can slope up at any amount of steepness, but it would still be going up. It could slope down at any amount of steepness, but still be going down. And why I say this one's up and down, because some people are always like, well, it's going down this way. But you read graphs just like you read English from left to right. So you read in this direction. So that means if I'm getting on this graph, I'm going up. If I'm getting on this graph, I'm going down. Then I could have a perfectly flat horizontal line or a perfectly vertical line. Okay, anytime our line is sloping up, it has a positive slope. It's rising, going up. If it's going down, it has a negative slope. Okay, now these two are special cases, and I want to remember everything about these kind of equations as being special. And I just have to memorize. I got to remember, hey, if I'm looking at a graph and it's perfectly vertical or perfectly horizontal, I don't do any of this. I don't do any of this, right? I want to memorize this flat one has a 0 slope. It's not sloping at all. It's like the tabletop you're working on, right? It's flat. It's not sloping. If it was sloping, your pencil would roll off. No slope. No slope. Okay? And so it's a horizontal line. The one that's vertical, we call it undefined. That slope is so steep, like if I were trying to climb up it, like I could climb up this and climb down that, but I can't climb this thing. It's too steep. It's undefined. It's so steep I can't even define it, and it goes with a vertical line. The reason we call it undefined is because the denominator, if you do plug in from a couple of points, you're going to get a number over 0. No, 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 right? We call that undefined. So I just got to memorize this. All right, let's practice that a couple of times. Find the slope, okay, and tell whether the line rises, falls, is horizontal, or is vertical. All right, so I've got 2 points. So I've got a formula for my points. I'm going to put it right here, my formula. Y's over x's, right? Y's over x's. I got to remember that. Rise over run. So I'm just going to plug into that formula, okay? And remember, xy goes in order. Xy goes in order. So -4 minus 1. There's my y's. -4 minus 1. Here's my x's. -3 minus -2. Be careful and get all your negatives in there. There's a minus as part of the formula, and the number has a negative. All right, so on top, signs are the same, so I add them. Keep the sign in front of the big one. On the bottom, I need to get rid of the stupid double signs. Okay, now on the bottom, signs are different, so I minus, 3 minus 2 is 1. Keep the sign in front of the big one. And now signs are the same, so it's plus 5 divided by 1. The slope is 5. Okay, let's do it one more time. Okay, negative 2 minus 3. Okay, 5 minus 5. Okay, signs are the same, so I add them. Keep the sign in front of the big one. 5 minus 5. Uh-oh. No, no, no. Undefined. Right? That's your slope. Don't leave that. Your slope is undefined. Okay, so it's just plug into the formula. We'll come back and answer this when we have all the slopes figured out. Now, something that's going to be real interesting and real important for us is if I don't have 2 points, if I have an equation instead, and notice now our equation has an x and a y. That's what's telling me I'm thinking about graphing instead of just solving it for x, right? I got an x and a y. Now, if I take this equation that has an x and a y and I solve it for y, remember when we did those solve for a specified variable? So I'm going to solve this for y, which means get rid of my fractions, get rid of my parentheses, put all my y's together, okay? And then undo what's being added or subtracted to the y. And remember then, the only difference is I can't actually combine those, so I'm going to leave it negative 7x plus 14. Then undo whatever's being divided by the y. And I want to do it all the way across, all the way across. So y is, now that fraction won't reduce, but that one will. Anytime my equation is solved for y, this number in front of the x, just the number, slope is a number, is my slope. Right? There's my slope. If you have an equation, solve it for y. Okay, let's do this one. Let's take off 3x. Two y equals negative 3x. Divide by 2. So y is negative 3/2 x. As soon as I get y is something, that number in front of the x, that's my slope. Okay, so now I know my slope on all of these. Okay, on this one, because it's positive, the line rises. This is undefined, so that means that line is so steep I can't even write a slope. It's not that it's horizontal. No, it's not 0. There's not no slope. It's a giant, giant, giant slope. It's vertical. And then because both of these are negative, these lines fall. Falls. Falls. Okay, so practice finding those slopes and that terminology, and let me know if you need anything.